Unit 2-3 brought to you by Unmasked, Demasked. I don't know, what's the best way to say that? Batman. Here's Angry Face, and of course, he's got Grim Face on the backside. Batman. Okay, so today we're going to figure out what's up with the rectangular coordinate system. We're going to check out data and their connection to graphs and how to interpret graphs. We've kind of already touched on this with pie charts and bar graphs, but we're going to look at a different type of graph today. Then we're going to note how slope is really just a constant rate of change, connected back to what we did in 2-2. And then we're going to make sure we understand how to interpret the y-intercept of a line. And ultimately, our goal is to write equations of a line. And the goal of that is to model data. Now, you're going to be expected to know how to write these equations from a description, from a table, or from a graph, either way. So let's take a look at number one here with this data. Our author says, hey, what kind of trends do you see? So here's 1992, and this data is the unemployment rate for that given year. We're thinking, what did it look like before this economic crisis of the late 2000s? And this is these unemployment rates. Notice we got 7.5 and a 6.9. These numbers seem to be getting smaller. 4.7. Oops, we're starting to go back up. 5.8, 6.0, going back down, 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 down. Oh, huge jump right here. I believe right in between 2008, 2009, that was the big Bear Stearns fiasco going on. So it seems to be what, start high, drop, then go back up kind of idea. And it was a little tricky to look at, to read, I think, although for someone who really loves numbers, you just look at that and you can kind of visualize, you can mentally think about what's happening and see it. One of the problems I think with this graph is that, or with this table, is this table really should be extended on here, and O2 should be right here with a 5.8. Due to space constraints, I suppose they couldn't get it in there, so they split it into two. Well, check out the graph. Hey, this is the exact same thing, the exact same set of data, but now you are presented with the picture that you might not have been able to create just by looking at the numbers. So you can see a clear decrease going on here. It's a slow decrease, then sort of a quick rise going back down, and then a really fast rise, and then it seems to be decreasing as we head into 2012 and beyond. What economists might start doing is looking at these data points and connecting things that are happening in the U.S., events that could be causing this sharp rise of unemployment, etc. It would be interesting to see how has this continued on if we included up to 2020's unemployment data. What happened in those 8 years? Of course, we've got 2019 right in here, the big pandemic, or is it between 20 and 21? Boy, hasn't life blurred itself? So it's much easier to see what's happening in the graph. And that's the point our author, what's happening with the data from a graph. That's the point our author is trying to make here. Some things that are important when reading a graph is to note the scale on the bottom. And we call this in the math world the x-axis, and the scale on the y-axis, and what those units are. So these are given in years. Now we often will write this as year since 1992 and call that value 0, just so that when we're actually graphing, we don't have to have these really big numbers to plot out. Notice we have steps of 1 between each one of these tick marks. And then on the y-axis, this is the percent unemployed. So these numbers are actually 2%, right? This line represents a 2% unemployment rate, which we never reached. This line up here is a 10%, and there's steps of 2% between each of these lines. So halfway between would be 5%. Okay. Note then, I just talked about that. Here's this idea of scale for the graph. It's always crucial when you draw it. You can make the scale whatever you want, and you may, encounter graphs with very unique, interesting scales, maybe on news reports, newspapers and television and the rest, where people might be purposely trying to mislead you by how they label their axes. And we'll look at a couple examples near the end of this section. Notice that 2002, we've got this, we can read that as 8.1 by following these lines, the vertical and horizontal line. So this vertical line represents that X value. This horizontal line represents that Y value. Where they intersect is an ordered pair that we would write as 2012, comma, 8. And if we kept the units in there, we'd put percents and note that that was years. And then in general, any ordered pair we write is X, comma, Y. That's how we read them. X first, Y second. Y, someone chose it way back when and we stuck with it. It's convention. You could flip those around if you want and it wouldn't make a difference. We could label this as the Y-axis, that as the X-axis, but we don't do that. So don't do that. Okay, now let's look at a non-contextualized version of this on page 135. So this is what we call the rectangular coordinate system. Most often you're going to hear it the XY axes or the XY graph. And what's happened is we've taken two number lines and smashed them together. So we took a horizontal number line, and you can think of this as 0, 1, 2, 3, thinking back to 1.7 as locations on that number line. And then we wrote a horizontal number line with this strategy, 0, 1, 2, 3, and then -1, -2, and -3, and we mashed them together. And the point where we connected them is these zeros. We call that special point, like it says number 3, the origin. It is right here. It's called the origin, and its coordinates are 0, 0. So the x coordinate is 0, the y coordinate is 0. When we put points into this graph, we call that plotting points. And so I'm going to plot these 5 points right here on this graph. So the first point is 16, 0. Well, wait a minute. We need to figure out what's going on with the scale here. So notice we are told that this last value is a 20, and then there's 1, 2, 3, 4, 5 tick marks from 0 up to 20. This tick mark is 0. So if we want to figure out the x scale, we have to ask ourselves, well, how can we divide 20 into 5 equal parts? Well, that's quite easy, right? Well, I shouldn't say easy. It's terrible for an instructor to say easy. It's simple in that we just take 20 and divide it by the number of tick marks that we have here, and there happens to be 5. So each tick mark represents 4 units. So to fill this in, it would go 0, 4, 8, 12, 16, 20. Oh, awesome. That worked out perfect. For the y scale, we'll do the same thing. Notice the top number is 50, and we have the same number of tick marks, 1, 2, 3, 4, 5. So we're doing 50 divided by 50. We're breaking that 50 into 5 equal parts, and that is 10 units. Since this is non-contextualized, the x and y are just unitless numbers. So we've got this as 10, 20, 30, 40, 50. That's what each one of these horizontal lines represents in terms of the number of units. Okay, so now our goal then is to plot these 4 points. So 16, 0, we'd go to the 16 on the x-axis, and we'd find where's y equal to 0, and it's right there on the x-axis. We would label that point A, 16, 0. The next one, 0, -10. Okay, so we've gone nowhere on the x-axis. We're right here, and we end up at the -10, which happens to be this point right here. That is our B value, 0, -10. All right, let's do something a little more interesting, something that doesn't contain a 0, and that is -8, -20. Well, I didn't label these, but it's the same scale as on the right side. It's just with negative values. So this tick mark is -4. This tick mark is -8. So here's where we're fixed on the x-axis. And then the y-axis is -20. So we need 2 tick marks. And there we are at -20. Notice all points on this horizontal line correspond to a y being negative 20. So that point there is negative 8, negative 20. Okay, and the last one, 1235. So here's a positive 12 for the x, and then 35. Oops, it's halfway between these, so we just do our best to hit that halfway mark. Here we are, 1235. All right, is this an essential skill? Yeah, I think it's important to understand what's happening, but we live in what, the 21st century? Is it the 22nd? I don't know. Some sort of century where our world is consumed by technology, and you have graphing calculators in your hands, in your pockets, 24/7 of your life. On your cell phone, you can download the Desmos app and graph anything you want. So I'm going to demonstrate how to do this in Desmos really quickly. So here's my Desmos graph, and I want the scale to be exactly the same as what we just did. So I click the wrench, and here you can see x-axis and y-axis, and I can make these scales whatever I want. So I'm going to type in the negative 20, just like our textbook had, and the positive 20, and I want those to be steps of 4. There, that's exactly the x-axis graph that is printed in your paper. See how easy that is? And then for the y, oh, there I said easy again. I'm really sorry, y'all. See how straightforward that is? How much less work that was than trying to draw it by hand yourself? Okay. And we want the y-axis to start at negative 50 and go up to positive 50 with steps of 10, meaning each major tick mark is worth 10 units. Look at how nice this is. It is perfectly put together, perfectly lined out. If I were to try to draw this by hand, it would be almost impossible. Now, here comes plotting points. Desmos understands that when you put parentheses in your calculator, there's your point. So I'm going to label this point A. There it is on the graph, exactly how I drew it. Here comes point B. It is 0, negative 10. Notice I have to type in the comma. We're going to label that as point B. There it is, showing up right on the graph. How wonderful. This is, to me, far more satisfying than trying to draw this by hand. Now, if you're an artist, I apologize, I might be offending you. Artists are great at graphing, and you can do things wonderfully. I am not a practiced artist, so I'm not good at that. Okay, and then on my last point, oops, I forgot to label this as point C. And my final point is 12, 35. All right, there is graphing in Desmos. Let me try again. There is plotting points in Desmos. Not a super useful skill, but important to understand how it happens.